Hey guys, we're back. Math 6 worksheet 2. Who's ready? I'm so sorry about the light. I don't know what I'm going to do about that eventually. Okay, who's ready? Math 6 worksheet number 2. Order of operations. PEMDAS, they're helping us. How nice of them. Okay, a little bit of PEMDAS. P stands for parentheses. Ooh, we got something to do in the parentheses. Let's do that. 3 minus 5 is, think about it, -2. If you're allowed a calculator, let the calculator do the work. Next step in PEMDAS, exponents. There's an exponent. We can do -2 squared, which is -2 times -2. Think about it. +4. Awesome, this is going smooth. And then we got multiplication and division, whatever comes first, left to right. I know that sounds a little weird. We won't really need that for this problem, but obviously we're going to do some multiplication. 2 times 4. That light's bothering me. 2 times 4 is 8. You could say -2 times 4 as well, so -8. Both work. And then 10 minus 8, last thing, subtraction and addition, 2. Answer is 2. That was very nice. Let's double check our work since I'm doing this for the first time. -2, 4. That is correct. So that was our pre-algebra question. Classic PEMDAS. Most of y'all are probably good at that. All right, Algebra 1, systems of equations. This is a little bit of on the easier side. So when they say solve systems, three things should come to your mind. We could solve it by graphing. That's when we graph it, see where they touch. We can use substitution. That's when you plug something into the other. Or we could use elimination where you cancel stuff, top and bottom. If you didn't understand all that, don't worry about it. We're definitely feeling some substitution here. We want to do substitution when we have a letter by itself, which we do. We have y equals 3x. So, since y is 3x, I can replace it with that y. So basically what I'm going to do is, I'm going to copy this whole thing, but instead of y, I'm going to put 3x. So watch closely. I'm going to copy the 2x plus parenthesis. Instead of y, I'm going to put 3x. Close it. Equals 20. So that was substitution. And we're not done yet. We got to do this baby math. That's just 2x plus 3x. That's 5x. You could drop your parentheses there. Divide by 5 on both sides. 4. X equals 4. Now this is half our answer. So what I like to do is I like to go like this. If we got y as 4, I would have put the 4 here. And this would be blank. But we got x equals 4, so we put it there. Nice. And then how are we going to find our y? This is the thing that all students remember. We plug it back in. So we're going to put the 4. We could choose either the top or bottom. Always use ones from the beginning. So I'm going to erase the highlights. Always use a question from the beginning. You can kind of pick which one you want. This one looks the easiest. So I'm going to plug 4 in there. 3 times 4, 12. Y equals 12. Done. Don't forget, you could check your work for this one. So we could plug that point into the other equation and really make sure that we're right. Watch this. This is extra, okay? Some teachers make you do this, but this is just extra work. So I'm plugging that coordinate in here and seeing if it works. 2 times 4, 8. Boom. There we go. 20 does equal 20. We're good. We found the right answer. So if I'm doing a test, like that feels really good. Like I know this is right. That's pretty cool. That was our Algebra 1. All right, now for geometry. Find the missing side length. I hope I'm moving faster than last time. I don't want to bore you guys. Find the missing length. We only got legs here. They're not asking about angles. We got a right triangle. Let's do some Pythagorean theorem. That's a squared plus b squared equals c squared. Remember, c is the hypotenuse. Let's do a little change color. Gotta do it once this video. So the hypotenuse is c. The others, it doesn't matter who you call a and b. I'll just do that. And remember, our formula is, I'll write this one. Everyone knows that one unless you're just starting out like algebra or something. So technically a lot of students could do this problem if you're a parent watching this. That's why I recommend the students at least try every problem. Obviously pre-calc, a lot of people are going to get stuck at pre-calc. Dang, that light looks like the sun. Okay, so let's do this. So we got a squared, which is x. So x squared. B is 3. 3 squared. C is 7. Nice. That was that's like I wouldn't say the hardest part, but that was the tricky part. So now, a lot of students, the mistake would be they think that they'll think that 7 was like A or B. So they wouldn't know to put 7 on the C. That's the biggest mistake probably for this problem. I just squared these. You could use your calculator if you're allowed. 3 times 3, 7 times 7. Subtract 9 both sides. Easy. Ooh, what do I do here? A lot of students get stuck here. I got x squared equals a number. I can square root both sides. So x equals square root of 40. By the way, if this was any other problem, we would have said plus or minus square root of 40. We just don't do plus or minus for distance because this can't be negative. It's a length. Okay, square root of 40. Some teachers, they're nice. They're like, hey, let's just plug in the calculator. In case your teacher isn't so nice, you'd have to know how to reduce this. So, how do we reduce radicals? I like to do the tree method. So I'm going to take square root of 40. We'll do it over here. We're going to tree it out. That means like keep dividing it. A lot of people like to do 2s, so like 2 and 20. You can keep doing 2s or you can go a little higher. 24 and 5. 4 times 5 is 20. This is oh, that's not going to look good. Let's make it smaller. This is a method used, you usually learn this in like 5th grade, so I know most of y'all are going to understand what I did there. So then we look at the numbers that ended, okay? This is my way of doing this simplification, okay? A lot of teachers have different ways, but I'm going to get rid of every number that had branches. Okay, so 4 had branches, 20 had branches, 40 had branches. These are the numbers that are left. And now I'm going to circle doubles. So what do we see doubles of? I see 2 2s. See them? Boom. I could have circled those, but I just chose these. And then I don't see any other doubles, okay? I don't see 2 5s. I don't see another 2 2s. Whatever you circle 2 of comes out once. So we draw a new house. 2 2s. 1 comes out. So these 2 2s is that. The rest go inside the house, and they multiply. So a 2 was lonely, and a 5 was lonely. We put them inside. 2 times 5 in the inside is 10. Okay, if you, there will probably be more problems where we have to simplify these if you're following Math6. So, you know, we'll get more practice with that. I'm not going to go into detail about these radicals. They'll definitely show up later as we do more worksheets. 2 radical 10 is our answer. That is called the exact answer, by the way. If you put it in your calculator, you'll get a never-ending decimal. Irrational. Okay, let Mr. Raider get some water. This is crazy. I'm working like a dog here for you guys. I think we're doing faster than last time. Okay, factoring. Okay, I love this question. I want to show you guys the easiest way to factor these trinomials. Okay? First things first, you got to take out a number if you can. Can all these divide by something? The answer is no. If they did, you would just, like, let's say they all divided by a 2. You would divide all of them by 2 and just write the rest right here. But they don't divide, so that doesn't count. So what I like to do is called the big X. What goes on top of the big X is A times C, the front times the back. 2 times 3, 6. The middle number goes on the bottom. Now this is the magic riddle. Two numbers that multiply to 6 and add to 7. What are the two numbers that multiply to 6 and add to 7? So you would list out your factors, 1 and 6, 2 and 3. 2 and 3 can make 5. That's not good. They could also make 1. That's not good if you subtract them. 1 and 6 can make 7 because you could add them and get 7, right? So 1 plus 6 is 7. 1 times 6 is 6. Obviously, it's a lot harder if there's negative numbers. But if you're good at it and can find the two numbers, the rest is all easy, the way that I made it. Okay, I'm getting a little color happy here. So now we're going to put fraction bars under both of them. And what you do is you put this front value on the bottom of them. So see the 2x? You're going to put 2x on the bottom. You reduce the fractions as much as possible. So this one, reduced. We're done. This one, though, we could reduce by 2's. Divide by 2, 3, divide by 2x. Always keep your x on the bottom. And if you add a negative, always keep the negative on the top. Now what we do is bottoms up. So the first parenthesis is 2x plus 1. The next one is x plus 3. And then that's it. That's called the big X theorem. So if you like the big X, keep practicing it. It's the easiest way to do these, in my opinion. If you're in pre-calc, there is the guess and check method. Also good. Okay, so whatever floats your boat. We're going to do more of these as we go on. Pre-calc. Remember, I'm going in these blind, so I might have trouble with some of them. Trig equation. Solve x for the interval. So, I see this. This just means like your answers need to be in between that. So, when I see this, I'm like, let's get cosine by itself. So I'm going to add the 1. Divide by 2. I have cosine x equals 1 over 2. Now for my pre-calc students, this is the unit circle. If you haven't learned the unit circle, you will. And I can't pull one up right now. Maybe I should have been prepared, but I can't pull one up right now. You can Google it if you want. But on the unit circle, you're looking for where cosine's x values. You're looking for where the cosine is 1/2. So if you were looking at the unit circle, we know cosine is 1/2 positive x values in the first and fourth quadrant. Now you just got to know which coordinates, or which radians, because the answer's got to be radians. Which radians is cosine 1/2? And if you knew your stuff, you knew it would be at pi over 6. And this one is, I might get this wrong. Oh, made a mistake. It's not the pi over 6, it's pi over 3 family. Whoops. So pi over 3 is the 60 degrees. That kind of looks like it's the 30, but it would be more like up here. But I'm not going to rewrite it. So pi over 3, and what's the next one? I believe it's 5 pi over 3. Yes. That's the fourth quadrant. And then there we have it. So the reason why I only cared about those is because we needed to pick values in between 0 and 2 pi. That's basically the unit circle. And there you have it. So if you Googled unit circle, you would see these two coordinates at pi over 6. Sorry, pi, I keep doing that. Pi over 3 and 5 pi over 3. Okay? The other ones don't work because those are negative x values. We needed positive x values. And remember, I'm kind of going in the rabbit hole here, but cosine is your x values, sine is your y values, tan is your y over x values. Okay? This is basically a unit circle question. But these are your answers. Very cool. All right, now for the SAT question. Percentages. Okay, this probably falls into a hard pre-algebra question, decent for algebra 1. So, this isn't the hardest thing in the world. But we definitely want you guys to get this right so you go to a good college. A laptop is on sale for 20% off. The original price was $800. What is the sale price? Huh. So this is the original, and you're about to get a discount of 20% off. They want to know the new price. There's a couple ways you could do this. The average student would definitely look at the multiple choice answers. We're gonna do no multiple choice just because we should know how to do it regardless. So what the average student's gonna do is you're gonna do 800 times. You're gonna change 20% to a decimal. So we got 20%. The easiest way to do it is to divide by 100, and you would get 0.2. So that's the decimal form of 20%, and we're going to times that by 800. Okay? I got my calculator. 800 times 0.2. Remember, SAT is all calculator now, the digital. Hey, the answer is 160. No way, right? I bet you the answer choice is there, though. It said, what's the sale price? That's how much you're saving. If you're going to get something for $160 and it was $800, snag it. That's a deal. But that's how much we're saving. So how much are you going to spend at the register? Maybe 800 minus the 160. That'll give you how much you're spending. Okay, so 800 minus 160. $640. That is the sale price. That's the way to do it. Like the average student's going to do it like that. The way you could do it really fast is if you know you're going to subtract like that. Like notice how we like found the 20% and we subtracted it from the original. The other way of doing it, let me write a different color. I'll write it in red. The other way of doing it is you could take your original and you times it by the reverse of the 20%. You could think of it as like, how much are you buying? You're not buying 20% of it. You're actually buying 80% of it, which is 0.8. If you could think of that, like, I'm going to say it one more time. You're saving 20%, but what are you really spending? You're spending the rest, which is 80%. So if you're good at that, you can kind of shortcut this. And if you put that in your calculator, remember, I kind of skipped this step. Remember, 80% divided by 100, 0.8. That's why that's there. So, and we don't really need the 0. Oh man, I'm being picky. I didn't need to do all that. 800 times 0.8 will get you right to the money. Think smarter, not harder. I am sure if all of y'all knew how to do the red, you would do it. Look at how much work that was compared to everything else. All right, well, there you have it. Remember, when this is, if sign up for my, if you're interested in having these emailed to you, blank, that your student or yourself can do on your own, go to www.math6boca.com/practice. If you sign up there, you'll be on the email list, and it would like basically send you a blank document of all this. And you're basically the student that needs extra support would do it. And if they need help, they can click this button, and it will go right to the time in the video where I go over the question. Pretty cool. Anyways, this was number 2. I hope y'all liked it. I will see you next time.